All right. Can you see my screen here? The AWS login.
The step in Octopus. Yep.
Yep. Okay. Cool. All right. So this support workshop was based on a couple of tickets that have come in lately, mostly to do with Kubernetes, but the principles I think can apply to a few other steps. And basically, the underlying issue of these support tickets is that things like health checks don't work, or maybe the steps don't connect to the cloud services properly. And people struggle, I think, to diagnose at which point in the chain the error occurs, because there's a couple of different parts to getting a step to work on a cloud provider. Things like the credentials, how the logins are actually processed, where things like certificates come from, things like that. These are all potential points that can fail, and working out at which point in that process something went wrong, or who supplied the information that went wrong. Was it something configured in Octopus? Is it something on the worker or the target? Is it something from the cloud provider itself? So these are all important things to understand from a support point of view. And so what we'll do here is just run through the process of what a typical deployment looks like when it involves a cloud provider, and some of the debugging techniques you can do to narrow down a particular problem. So the first thing to understand is, what does it even mean to run against a cloud provider? So we have steps like these AWS CLI. This one here, we have a similar thing for Azure. Run a script step, and we do have targets like Kubernetes that run a lot of scripts against these cloud providers as well when the Kubernetes cluster is hosted by them. So what it actually means, or the first step in these processes, is that Calamari will actually, before anything is run, so for this script step here, before we actually even get to the script, Calamari is going to execute a number of login processes, and they are unique between the cloud providers. So AWS logs in differently to Azure, for example. And it's only once those login processes have succeeded that we get to the point of actually running a script. And so for AWS, the process of logging in is to generate these environment variables here. And so these are environment variables that all tools built to talk to AWS understand. So these are standard names that AWS itself has documented. And so Calamari will take the credentials of the account that you've provided and then run through a login process to, with the end result being that when a script is run, these environment variables exist. So what I've done here as a test is dump these out to the console. Secret key will actually be masked, because Octopus knows that it's not something that should go to the console. And then we have this call to the AWS CLI, and this get caller identity is just kind of like a who am I style call that shows the identity of the person who's logged in. And so I've run this here, and as you can see, the AWS key has been exposed as that environment variable. This would have been the secret key, but it's just been masked out. This was the default region, and this was the result of that AWS CLI command being called. And as we can see, it's successfully identified the user here. The Azure CLI login process is similar at a high level, in that a login process happens before we even get to the script. But what actually happens for Azure is that we run the AZ login command. So the AZ being the Azure command line tooling that they provide. And so what's going to happen here is that in the background, actually I can show you this as well, because it's actually this script here. So this is the Calamari source code. might zoom in so everyone can see it. So this is the script that gets run, and this AZ login command here is what's actually getting called before the script, before your custom script is run. And so if we go in here, what we're going to find is that a directory called Azure CLI is created in the working directory of Calamari, of the particular deployment. And inside there, the AZ login command saves a file called Azure tokens.json, I think. We can look at that in the logs. And so that file is how Azure knows to extract the credentials that were generated by the login command. And again, that's a standard convention of the Azure command line tooling. So anything that is designed to run against Azure will know to look for that file there. So what I've done here, I'll dump the contents of that directory so we can see those token files. We'll run this command here. That's the Azure who am I style command. And what I'll actually do also, because this will lead into the next section, is run the AKS get credentials command, and that's going to generate a Kubernetes config file for us. And we'll lean on this later when we look at the Kubernetes targets, but I just want to show here that how these commands work and the kind of outputs they generate. So if we go to the result of this, so what we can see, this is my directory listing, and somewhere in here there's going to be a access tokens, right? So that there contains the credentials that the AZ login command generated for us. And because this is inside the working directory of Calamari, it'll get deleted automatically once the process is finished. This is the result of that AZ command getting the details of the current user. Yeah, and again, as we can see, it's successfully found the user details that we supplied as the account for that step. So somewhere in here, this would be the result of that AKS get credentials command. And if we look in here, my config file, that was the output file that the AKS command generated. And this is something that you could use with kubectl directly. So we'll see how that works later. One thing to note though with that command, the AKS command, is that we never supplied any, all we supplied was the resource group, the name of the AKS cluster, and the output file. So what this tells you is that the contents of this file is completely generated by the Azure command line tooling. We're not inputting any manual user credentials. We're not inputting any certificates. We're not inputting any URLs, for example. So the contents of this file is completely generated by the AZ command line tooling. And so that's important to know because one of the questions obviously you have to work out is when you're debugging is who supplied the details that are potentially incorrect. And certainly for AKS clusters that use these logins, the contents here are all supplied by AKS. So we don't really, there's nothing we actually input into that file. And so we don't have any control over it. So the, excuse me, when it comes to targets that use these credentials as part of their login, it's the same process. So what we'll have here is AKS. This is an AKS cluster that I created earlier. We've set the authentication type to Azure. And you'll notice here, these are those same two command line arguments that we passed in that previous script. So what's actually going to happen there is, if we look for AKS, actually, I'll try and dig that up later. But there is a script that generates the Kubernetes config files. And all it's going to do is call that same AZ AKS generate credentials as the config file and then execute the health check So if we look here, we may not see much in the logs, but we can kind of get a sense of where things are happening. So here, that's the output from the AZ login command. That's that wrapper that is going to be called both here for targets and also for things like script steps. This is some general debugging that we do for all Kubernetes targets. This merge thing, so that should look familiar from that last script step that we did. This is the result of calling AZ AKS get credentials. And then all we're doing is running kubectl version to verify that the cluster can be contacted. And so what's happened in the background is that this file here was generated by the AZ command line tool, and then we just call kubectl referencing this referencing this config file. It's a similar-ish process for EKS. So what you'll see here is that we select an AWS account, and we supply the name of the EKS cluster that we created, as well as the master API endpoint here. You also notice that we can supply a certificate that is used to ensure that these HTTPS calls are considered valid. This is usually self-signed and untrusted, but it's just something you can get from AWS itself. And we've saved that as a certificate in Octopus and then referenced it here. And so that's important because unlike the Azure CLI command, which generates the config file for us in its entirety, what we actually need to do for EKS is generate most of the config file ourselves. And so that includes putting in that certificate. So that certificate does come from us. So for EKS, if there are certificate problems, a potential source of that problem is a certificate hosted by Octopus itself. And I've simulated an unhealthy target here. So this has just had the name of just created an incorrect cluster name. And so the authentication here will fail because this cluster doesn't exist. It's not a real thing. And I did this because if the credentials of a cluster are incorrect, the support ticket will most likely come in saying the health check failed, right? That's the first thing that gets done. And if it's unhealthy, most people will just stop there and report the error. But actually, it's far easier and far more useful to use a Kubernetes CLI script step to try and debug these targets. And the interesting thing is, by default, these script steps still try to run on unhealthy targets. You can actually, I mean, obviously you can bypass that process here, but by default, the script will still try and run. And this is really useful for us in debugging because it means we can let Octopus generate the config file for us. And then we can go in a script step, which will still run against that unhealthy target and start debugging what went wrong. So what I have here is a sample script step that highlights a couple of the potential issues that may come up in a Kubernetes target. So first of all, we expect some of this to fail, so we just let PowerShell continue in the face of an error. What we've done here is written out those AWS environment variables. So this is confirmation or not that those credentials have been generated properly in the context of our cluster. This one here will show the details of the profiles of the Azure login. This isn't actually the token file. This one here just kind of lists the, I think it's the subscription and details like that. I don't think there's anything sensitive in this particular file here. You could, if you wanted to, list out those token files as well for extra verification, but you just have to be aware that that's going to put some sensitive details into the logs. This command here will dump the contents of the generated Kubernetes config file to the screen. The nice thing about this is Kubernetes will redact any sensitive information. So this is a nice tool you can use without leaking anything potentially sensitive. This is just confirmation that we've set the kubeconfig environment variable, and that should link to the path of our generated Kubernetes config file. So this is how we override, perhaps if a machine already has a default config file in the default location, we won't use that. We use our own here that's created and destroyed with each deployment. What you can do if you really need access to the, actually that's wrong. What you can do if you really need access to the config file though, is actually just save it out as an artifact. Again, this is going to leak sensitive information to the log, but this is useful for people if they need to get exactly what we generated and test it outside of Octopus. So that's a useful debugging technique too. Something to be aware of is proxies. kubectl does respect proxies that have been defined, and the details of the proxies are in these environment variables. So this will capture the state of any proxy configuration that a customer might have. And proxies can be a pain. I think we've all seen it. So it's good to confirm or deny that a proxy is in play here. And this is actually the script that the health check runs. So what we're simulating here is exactly what a health check does. The Kubernetes health check is performing a script step with this command in the background. So this is useful for being able to simulate and debug the process of a health check outside of an actual health check process, because obviously we can enrich this with whatever scripting we want. The other useful debugging technique is to get people to supply their own Kubernetes config file. So a lot of people will obviously have a config file that they've created outside of Octopus to work with their cluster. And so if we save that here as a custom file, we can rerun this version check with their custom config file. And so this is a really nice way of taking a config file that someone can or has used outside of Octopus, and presumably it works, and put it inside Octopus and have it have that config file be used to perform what the health check ends up performing. So if we look at the end result of that, this is my unhealthy cluster. Obviously, it's not going to work. None of these commands will do anything useful, but we can see that all the debugging that we have in the script is running, even though that it's unhealthy. So we can see here, that's the faulty cluster name that caused the health check to fail. But as a debugging exercise, I can see that the AWS credentials have been exposed correctly, as I expect, in these environment variables. Obviously, there's no Azure user and no files to inspect for the Azure user, so that came up blank. We can then see the contents of the generated Kubernetes configuration file. Yeah, and we can confirm that it's the authentication is deferring out to this external executable, which we expect, the name of the cluster, things like that. This is also important here. We can see that the kubeconfig environment variable has been correctly set to the temporary file that's generated. So that's what we expect. And this here is the contents of this, more or less. If we did have credentials in here, this kubeconfig view would actually obscure that. Actually, we can see that probably in AKS. Right, so it does kind of redact anything that's sensitive. No proxies to speak of. We've simulated a health check. you'll notice actually that successful health checks come back with client and server version. This is only come back with client version, and that's a failure. You can always get a client version because that's just the version of kubectl itself. You only get a server version if you've successfully connected, which we haven't here. And had our custom config file been something that was valid, we would expect to see the server version there, but because it was just a mock file that doesn't point anywhere, it too has failed and doesn't produce that server version. What we might do, if we look through the AKS one, we can see obviously the AWS credentials don't exist, but this is the contents of that profiles JSON file. And from that, we can determine that, that the login has most likely succeeded. This information can only have come from Azure. We didn't supply anything called Developer Playground, so it's a good check of the success of that login. And again, same deal. We have the output of the config file. We have no proxies. Our health check has succeeded. We got the server version, but our test, our custom config file has failed because it didn't return the server version. So that debugging in these script files is far more powerful and far more useful than trying to debug a health check. As you can imagine, like what information can you get from here? It's kind of limited, right? It's not really showing us, doesn't show us the, I mean, you can maybe extract information from that. And this here is actually the key that failed, but it's not as easy to get anything useful out of this. So step number one, when people say my Kubernetes target has failed a health check, is to forget the health check and go and create a script step and start debugging it through there.
Do we have that listed anywhere, like in our docs or anything? The debugging scripts that you were showing?
No, actually, I just kind of wrote that in the last half hour. But
oh, cool. All right.
We probably could. I guess it makes sense. They are useful.
Yeah, it might be handy to refer to.
Yeah, no, that's a good idea. I'll do that actually after this, after we finish recording here.
Sweet, thanks.
So there are other steps that do use these logins as well. Terraform is a good example. Terraform is going to be a bit harder because we don't have a Terraform CLI step. So you're limited in the kind of inspections that you can do. It's not just random scripting. What I have here is a Terraform step that has both an AWS and Azure account. And this source code here, it performs no operations. So obviously there's nothing here that's deploying any resources. But what it's doing is capturing the Azure subscriptions and then saving that as an output variable, and capturing the AWS caller identity and saving that as an output variable. And so what we can see when we run this is verification of those same kind of credentials. So these are the available subscriptions. Again, you saw this from those CLI commands that we ran against the Kubernetes targets. Developer Playground means that the Azure login has worked as we expect. We'll also see this is the account ID of the AWS target. And again, that number there doesn't exist anywhere in Octopus. So what that means is we have successfully logged in with AWS, and those credentials have passed through Terraform and come back as we expect. A little bit harder. I mean, you kind of have to do a bit of Googling to try and find out how to get these output variables. But as a simple test case for ensuring that those logins work as we expect, you can use a script like this that doesn't perform any operations but just dumps the output variables. So actually what I did want to do, if I can remember where it went. All right, here we go. So this is the, so if you remember, this is the script that Calamari ran to do Azure logins. And this is the script that Calamari runs after this to generate the Kubernetes configuration files. It's a little bit wordy, but there's a couple of useful bits in here. So what we can see is if, yes. Right, so this is the, if the account type was an Azure Service Principal, we can see again that we've called AZAKS get credentials to generate that, that config file. So that's how Calamari is performing those actions. If it's not an Azure service account, then we assume we have to build up a lot of that config file ourselves. So all these commands here are stepping through each of the individual settings that are required and building it up. And if we look down the bottom, there's going to be a Amazon one. And this is where we build up that custom auth. So this shows you that the AKS logins are very simple from our point of view. We defer entirely to the Azure CLI. For other ones, we do actually build up a custom config file and insert quite a lot of the details for ourselves. So there's more chance that if an EKS cluster, for example, fails a health check, the source of the problem is probably a value from Octopus. Whereas if an AKS cluster fails, for example, there's very little that Octopus is actually doing to generate that config file. And so we'd probably be better off looking more at the resources generated by the the AZ command line rather than Octopus. So that is the kind of the high level overview of how all these steps work with their cloud logons. So there's a couple of takeaways for support that I think are important. So question number one is, right, my health check has failed for Kubernetes. What do I do? Yeah, ignore the health check and just go straight to a script step and start debugging with something like this. This is going to get you far more information a lot more quickly than trying to work through the health checks. Where do the credentials come from for when you're logging in? So for Azure, we've seen that it's the AZ login command, and for AWS, it's actually a custom class that we've written in C# to do the login through the AWS SDK. So Azure in this case is probably easier to replicate outside of Octopus. You actually can't really replicate the Azure login that we do outside of Octopus. But the end result for both are either these environment variables or token files for Azure in the Azure CLI directory. The next question is, well, it works like my my Kubernetes commands work outside of Octopus just fine, and they break when they're inside Octopus. So what do we do there? This is probably going to be your first port of call, is take that working config file that that the customer has working outside of Octopus, chuck it in a script step, save it as a file, and start running commands like this, referencing that custom config file. This is useful because if it worked outside, it doesn't work inside, then you're going to have to start looking at things like proxies, like what's happening here, or what's the difference. The other thing you can do is run a command like this to get the generated config file as an artifact, and then just do a text compare between what we generate and what works for them. And you can probably identify what the difference is and what the solution may be. And the final step for things like Kubernetes is just don't use cloud auth at all. So you'll see we have a bunch of authentication types. And a token is, all Kubernetes clusters will support token auth. Obviously, an EKS cluster is never going to support Azure Service Principal, and AKS cluster is never going to support AWS. But tokens are very easy to generate, and all clusters support them. So the token comes from a service account, and we have some documentation on how to create service accounts with the correct permission. And if you have a cluster that uses tokens, none of these scripts here are going to come into play. Like these just won't be run anymore at all. And we've eliminated any of these login processes as the source of the problem, which means if there's still a problem, it's probably networking or maybe Kubernetes credentials or permissions rather than the actual cloud provider itself. And that's it. That's all I wanted to show off. Did you have any questions?
No, that was very thorough and enlightening.
Okay, thanks. All right, well, I'll actually make a copy of that script file in our docs. So
Yeah, that'd be cool to be able to check out.
As a copy and paste first step. Yeah, I'll do that after this, after we close up here.
Awesome.
All right. Well, thanks for listening. And
Yeah, thanks, Matt.
catch you next time.
Have a good one. Bye.
See ya.